Hey everybody, I'm Zac.
And I'm Jesse.
And you're watching In Depth.
On Now You Know.
Sponsored by A Better Route Planner.
A Better Route Planner makes finding chargers an intuitive experience. When you're zoomed out, the highest power charging stations are displayed. When you zoom in, more lower power charging stations appear, helping you find the best charger on your way. Another feature making this a better route planner. And brought to you by Build Your Own Robot Kit, or BYOR. Bring robotics to the kids level.
And we're brought to you by ecoware.us, where we have new designs uploaded every week, and we carbon offset every product so that it's carbon neutral. And on top of that, we plant a tree for every order. So Jesse, buildings are dumb.
I didn't realize that buildings had to be smart. What do you mean?
Well, I mean, they're pretty much the same as they've been for decades, right? They're not evolving at the same rate that, cars are evolving, for instance.
Right, but I mean, buildings don't need to do anything that fancy. You just need to, be able to go inside them. It keeps the rain off of you. It keeps you warm. Place to put all your stuff and to sleep, and that's all you need, right?
But don't you think that's weird that we've just been basically building buildings the same year after year, and we don't make, like, for instance, the heating and cooling systems? I mean, they haven't really changed at all in how we heat or cool a building in decades.
Right, but I mean, you have a thermostat, you set it to whatever temperature you want, and then it pretty much maintains that temperature.
But that's such a waste of energy.
How is it a waste of energy?
So let's talk to the Chief Technology Officer, Jean-Simon Venne. He's working for a company called BrainBox AI, and they're doing some pretty amazing things to make buildings smarter. So I'm fortunate to be talking today to the CTO of a company called BrainBox AI. And I guess what really intrigued me about you guys is that you claim that buildings are kind of dumb. And I'd like to know more about what you guys are working on. What are you guys building?
Well, we're focusing on the commercial building themselves. For us, the residential is, of course, quite interesting, but really the commercial building, like when you think of a hotel, office tower, airport, data center, are consuming so much energy that it's a very attractive target to try to optimize as a first step.
Now, when I think of a building, I don't think of it as taking up that much energy, like you said, a commercial building. I think of factories and power plants, those taking a lot of energy. But when I think of like a hotel or an office building or something, it doesn't jump out at me that they use that much energy. Is it a big energy user? Yeah,
it's I mean, usually like commercial building, if you remove a manufacturing plant, big industrial plant, are consuming about 1/3 of the energy on our planet. And it's because of the sheer size when you think about it. I mean, just look at Manhattan as an example. All of these high-rise, they're operating 24/7 all the time, and we keep adding more of them, right, as we're evolving right now. So it's the case in all of the big cities right now. I mean, you look at a T-crane everywhere, it's incredible the quantity of new building being built, but we also have all the existing, that are been out there consuming energy for the last 40 years, right?
And so how is it possible to reduce the amount of energy that these buildings use?
Yeah, so that's a very good question. I mean, the way HVAC, like all of the heating, cooling, and ventilation in building has been built over the last 60 years is built on rule base and schedule. So you're going to implement a schedule in the building and say, well, I start my system at 6 a.m. and I stop them at 8 p.m. If it's an office tower, if it's an hotel, it's going to be 24/7. But and then you basically operate everything based on rules. So the rules are based on a typical day. So let's say we have a typical day in July, which is going to be an average temperature, and you're going to build all of your rule base for that typical day. Now, how many times are you going to have that typical day in the month of July? You're probably going to have it once or twice if you're lucky. All of the other day, you will not be going through that typical day. You're going to be either it's hotter or colder, and then your settings are not at the optimal position to accommodate that specific day. And that's where you start to have an interesting space where you could start to optimize. So you want to basically have your rules adapting themselves on a daily basis so they always follow what you're really having as a day in terms of weather and in terms of user behavior inside the building.
That sounds great, but if I'm a building owner It also sounds kind of expensive. Like, to make my building that smart, it seems like it'd be just cheaper to ask guests to shut the lights off when they leave the room.
Yeah, you're absolutely right. I mean, if you were throwing people at it, so let's bring a team which will always calculate what is the optimal configuration you should have right now, you're probably going to need like a team of 5 or 6 engineers doing that full time. So very expensive. Nobody would want to pay for that. Let's not do that. That's exactly why we looked at this and say, we need to do continuous commissioning, and that's a technical term that we're using in our space. So we need to do continuous commissioning, but done by people is too expensive, and there's just not enough mechanical engineer out there to do the entire building stack on the planet. So even if people were willing to pay for it, it will be impossible to offer as a service. But wait a sec. I mean, look at what they're doing with autonomous car. They're able to drive a car on the middle of the street, calculating everything going around it in terms of other cars, in terms of the pedestrian, in terms of the cat crossing, and they're not killing anything or any animal or anybody. So we could use the same technology to do continuous commissioning in the building without having any human. So you do the same with a couple of penny on the dollar.
Okay, so I don't have to hire a bunch of people to do it, but what do I have to spend to get this to make my building efficient?
Well, you need time. I mean, basically, you need to deploy the AI, which will need to learn about your building, how your building is behaving in different conditions. So you need 1 or 2 months of learning, and once you pass through that time, the artificial intelligence understand exactly what make your building tick and what's going to be happening. And it's at that point is able to predict exactly everything that's going to be happening in each of the rooms in your building for the next couple of hours. And when we reach that level of learning, it's able to identify in that near future everything that you don't want to happen and change its strategy to basically have the best possible course of action to optimize energy and also at the same time reduce comfort issues. So that's where the AI is very good at, predicting to take preemptive decision, which are shifting your typical reaction type of building into a preemptive type of building.
And so how does the AI work? Because, I mean, I think when a lot of people think of AI, they're either thinking of some kind of holographic, humanoid, blue, like, I'm afraid or they're thinking of HAL. How does the AI interface with the HVAC system, and how does it learn?
Yeah, well, first of all, I mean, back to the basic of AI, I mean, we need data. That's the fuel for artificial intelligence. So, I mean, what's interesting with commercial building is they already have an incredible amount of data available, but nobody's really using it. So think of all of these thermostat, all of these sensors on the pump, on the boiler, on the chiller, on the ventilator. These electrical motor have tons of sensor, and they're really used for action, reaction type of control. And the data is usually not kept or used in any other type of fashion. So the data is already there. So we just need to connect to the existing control system, extract that data in real time, feed the AI so it could learn from it. We're also enriching in that data with weather data. So we're taking all of that weather happening in the same time that we're extracting that data from the building, and we're putting all that together. And this is how the AI start to learn. Now, if you dive into how do we apply AI, well, there's no robot. You're absolutely right. There's no holographic image either. It's all about neural network. So we're using the latest of the latest in terms of neural network, and we're feeding that data into the neural network, and the neural network is learning. And when it's become very, very, very accurate in terms of predicting what's going to be happening, then we could start to use it to do the command and control. So at that point, it is the AI algorithm that will decide if you should start that pump, if you should start that ventilator, if you should open the damper, and it will understand that, oops, the sun is coming up, so we're going to have a heat load happening on the south side of the building, so preemptively we will prepare that side of the building to face that sun. Well, that exact situation will be different in the next day if it's cloudy, because there's no more sun. So we're going to be acting differently on the same side of the building since it's cloudy. Now, wait a sec, what is the cloud thickness? And depending on that cloud thickness, it's going to be a different variation of what's going to be the exact best strategy to apply for that exact same location. And what make AI very powerful here compared to the human is the fact that when you look at the high rise, like in downtown Manhattan, you could easily have 60,000 data point on one building. So try to compute 60,000 point every 5 minutes and decide what is your best settings for all of the floor every 5 minutes. Feasible by human, but you're going to need like an army of engineers to do the same. So the AI is doing that for a few pennies.
Wow. That, I mean, what you're describing, it sounds like what I would imagine, the Starship Enterprise would have on board, like some kind of computer that's constantly, doing all sorts of different math, but it's a building. And for so many people, a building and controlling a building just looks like a thermostat on a wall that sometimes you just hear go like click, and you're like, oh, I guess it's on. But now you're saying that you're having everything in the building is basically connected to the AI, and the AI is learning from everything in the building, including pumps and ventilators and stuff like that?
Yeah, we're doing the entire HVAC side. So we're not doing the elevator or the lights. Now, we could have a debate. I mean, do you need AI for lights? I mean, on, off, really? Maybe not, right? An elevator, I mean, there is some kind of optimization, when you want to optimize the movement of them, but they're already using AI, depending what vendor you're using. So, I mean, there's not much you could gain there. But on the HVAC side, there was, for the last 50 years, very little innovation in that space. So it's bringing the AI in that space. It's creating a lot of value very quickly.
Now, why is that? Why haven't buildings been evolving slowly to get smarter? Why is it that they pretty much stayed dumb for decades?
When you think about it, you have a building. Let's say you're operating an hotel. You're the building engineer of the hotel. I mean, your job is to make sure that everything works properly, right? So once you establish rule base which are working and giving comfort to everybody in all of the room, in the bar, in the pool, and nobody's complaining, as a building engineer, it's you reach the status quo of the equilibrium where you're going to have a nice job and everything's going to be all right. Your day-to-day now become things which are breaking down. A mini bar not working in one of the rooms, so you need to change that mini bar. The beer dispenser in the bar is broken, so you need to fix that before happy hour, otherwise you're going to be in great danger. So I mean, that's become your day-to-day, and why should you go revisit how much it's costing you to produce that cold load or that hot load in different places? It's working fine, everybody's happy. So it's that status quo, which is basically not looked at. And keep in mind that if you really want to optimize that part, you're going to need to do a lot of crunching, number crunching and calculations. So do you really want to dive into that, or are you just going to move on to the next little problem to fix?
So the idea that because all the humans in the hotel or the office building are happy, they're at the, some temperature that's fine. They're not thinking about that office over there that's empty, that's currently sitting at 73 degrees on a cold winter's day. They're just like, well, as long as we're happy, there's, all these other little problems. They're just, maybe that hotel room is always a little, warm when it's empty. Oh, who cares? They're not thinking about efficiency. You don't have like a little efficiency person in each room saying like, you're not being efficient in here.
Exactly. I mean, and there's a lot of different components where you could save. So we have one algorithm that does only one thing. It's calculating your optimal time start in the morning. So if you're an office tower, usually you were following your schedule. You always start at 6 a.m. You don't ask yourself any question. Depending on the weather, you could change that start time, because that start time was calculated on that typical day that we spoke earlier, to how much time do you need to reach the desired temperature in all of your floors. So the tenant, when they walk in to work, they're happy, they have the right temperature. But that time will change from one day to the next depending on what is the weather. Just if it's sunny or not will have a difference on how long it takes to reach the desired temperature. So we calculate that time. We change that time every morning, trying to optimize that start time. We're doing the same thing with the shutdown time. So it's 7 p.m. or 8 p.m. Well, with our system, it keeps changing every day depending on what is the exact optimal time for today, which is going to be different from tomorrow, and it was different from yesterday. But when you look also at the thermal load of the building, I mean, you don't need to produce the same level of quantity of hot water or chilled water to cool down your office space every day the same quantity. It need to be adjust based what you're going through on term of what you're going to have custom made today as a day. So that when you start to do all these things and modulate in a dynamic fashion instead of following the typical schedule and typical day, you are saving in between 25 to 35% easily.
Wait, what? I was thinking you were going to squeeze out maybe 1 or 2%.
Yeah, so we're cutting down in between 25 to 35% of the total energy spent of the building, not just the HVAC. I'm talking about the energy spent of the building. So it's very, very significant. That's why for us it's very important to bring that technology in as many buildings as possible, because it really moved the needle. So imagine you deploy that technology in all the building in Manhattan. Suddenly, Con Edison has too much energy. It's that how you move the needle. So for us is we're finding ways where we could deploy that technology as fast as possible. So how long would it take to deploy that technology in a city like New York? We're designing it so it could be done in a few weeks. If we're capable of doing that, then probably like people at Con Edison will become our best friends.
Okay, so don't you have to wire up the entire building with sensors and thermometers and sun calculators and all sorts of crazy stuff?
No, that's the beauty of it. So the data is already there. The controller are already there. Everything is there. You just need to connect to that wire, extract the data, do your analysis, and then write back to the same controller which is already there. You quite easily could deploy that technology on existing building stack without adding any new hardware.
But you said, if I heard you right, you said in a few weeks you could turn Manhattan into a much more efficient city.
Yeah, so the way we're designing the technology right now, so you want to be able to upload the AI like you're uploading an app on your phone. So think how long it takes, and you want to be able to have as many people uploading at the same time as they want. So once they upload, you have to go through that learning period, which is something that you really, really hard to go around it. That's the nature of artificial intelligence. So once they upload and the AI start to learn about your building, then it will go through that 1 to 2 months of learning, and after that, it's just going to kick in and start operating your building. So it's a matter of how many people can upload this at the same time.
So can I get this straight? Are you installing some kind of computer system in a building that attaches to their HVAC system?
So right now we still have to install a connector so we could connect to these legacy control systems, which are not necessarily open to talk about the outside world. So, but we're at the same time working with several provider of control manufacturer, so they could embed that directly into their firmware. So then it will become like just an app that you activate then on your existing firmware that you have already installed. So that's a different way we're looking at it, so we could make sure that we deploy this technology as many buildings as possible, as fast as we can.
So you're seeing not only interest from frugal business managers who want to save money on their energy costs, but you're also seeing people who are like, my building doesn't heat and cool properly, so some rooms are too hot, some rooms are too cold, and they want to apply it just for that reason, not even to save money.
Exactly. So imagine, if you're a AAA office tower in downtown core of a big city in North America, your tenant are paying big bucks per square to be in that tower. And somehow the office of the vice president is always too hot. You're going to hear about it if you're operating that building every day. And they're gonna tell you that you're not doing a great job and fix it. And so if you try to fix it, but you're still not getting it right, using AI is quite interesting to say, okay, let's see if AI could fix it. Because maybe it's more complex than we think, and we didn't find the optimal way to configure that zone or that section of the building. So that's one of the reasons where people are using our technology, saying, okay, now we're gonna bring the AI to fix that comfort issue and make sure that vice president is now happy.
That's a really interesting point, because I thought what you were doing was basically just maximizing for saving energy, and so everyone would be coming into the office like, oh, ever since we hired these guys, it's cold, But no. So they can give feedback to you.
Yeah, absolutely. And in a lot of building, for them, the comfort, is very, very important. And they tell us that, yes, I want to save money, But make sure that you maintain my level of comfort or improve it. Otherwise, I'm not sure I'm that interested in saving money.
And so then the one thing that any building manager is probably not going to be thinking about, which is CO2 emissions and climate change, your system is going to be helping with that as well.
Yeah, de facto. And it all depends what's the sourcing of your energy. You're in Quebec. You could save as many kilowatt as you want. You're not really saving the planet because it's all hydro produced. So, but at the same time, you are, because if you're freeing up some kilowatt in Quebec, it could be served for other grid operator in the Eastern Seaboard, and their sourcing is probably not that great. So, depending what you're sourcing, if your electricity you're consuming is coming from a coal plant, or if it's coming from a nuclear, or if it's coming from a gas plant, you are saving gas emission, definitely. And that's one of the basic philosophy that we like to support here at BrainBox AI, is the fact that, we could have a lot of discussion about international 3D and make everybody agree on saving the planet. But at the end of the day, if we really want to save the planet, we need to use the technology in an intelligent way, where the application of that technology will create value and will save the planet while it's creating value. So we need to make sure that we're creating business by applying these technology where people are making money, they're doing good job at creating the value, but at the same time they're saving the planet doing so. And if we have more of these type of business model using technology, that's how we're really going to save the planet down the road.
How much longer is it going to be before a building manager could call you up and have you install something in their building?
Oh, we're already deploying all over North America as we speak. We're focusing only on the commercial side of the building. So, think of a hotel. We're deploying an airport now, office tower. Think about, we're doing some of the college campus, but we're just going to start now data centers, which are consuming a lot of energy. And we're trying to stay within that pool of type of building. We're going to also start multi-residential if they have a centralized system.
Wow. So you mentioned earlier that it could be just a matter of weeks that you could change over, like the island of Manhattan, into a more efficient energy structure. When do you think that's going to happen? How much longer is it going to take for some of these other manufacturers of controls systems to start putting the proper chips into their controls?
Well, we could wait for that, or we could just deploy it without it. So you still need to deploy a gateway at the building facility, and that's something we're doing de facto right now. So we're not waiting for these big legacy control company to incorporate that in their next version, which is going to happen, but it's going to take this due time. So we're going right now on the existing building stack and implementing these gateways so we could proceed right now. So it's really going per portfolio. So I'll give you an example. We're dealing with owner of large portfolio building, and right now they're testing it in a few of their building. If everything goes well, by next year they're going to start to deploy in their entire portfolio. So that's been our strategy so far. We're doing right now one airport. If it goes well, it's going to basically propagate into the other airport in North America, since they're all operating under the same type of HVAC system.
Wow, that's a really exciting technology. I think, we report on this channel all the time about climate change and what can we do, but here you guys are using AI for something different than what we usually talk about. We talk about cars a lot, autonomous cars.
Or we talk about energy generation, so we're usually talking about solar or wind, but, it's how you put that energy to use and to not waste the energy that you do produce. So very interesting, the amount that you can save and the how that can actually help save the world.
Yeah, when you think of the building, all of the building right now, they're operated on a reactive mode. So you reach the temperature in the room, which has become too high. It reached what we call the cooling set point. And then when you reach that threshold, the system reacts to it. It will start pushing more cold air in that space until the temperature goes back down. By operating it in a preemptive manner, you're going to prevent that event from happening. So you're going to be having less comfort issues, but you're going to be spending less kilowatt by have a smoother ride into that temperature fluctuation in that room. Think of back to the car. If right now the way HVAC are operated, it will be like you're driving your car, which you're only allowed to press the 2 pedal one at a time, but never press no pedal at all. So think about, you could brake or you could accelerate, but you could never do anything else than these 2 actions. So it will not be a very comfortable drive, and you will be spending a lot of energy for nothing. So we're doing exactly the same for HVAC, a smooth drive where you preemptively know that there's a red light, and I'm not going to press the brake at the last minute, but I will slowly slow down as I'm getting closer to that red light, and not pressing the accelerator pedal, because I don't want to spend that gas for nothing. Anyway, I'm coming to a full stop in about 20 seconds. So that's how AI is basically changing the way HVAC is operating the building.
Now, you mentioned that it takes a month or 2 for the AI to get enough data to start being smart. Does it keep getting smarter? So, I mean, a couple months is good, I'm assuming, for data, but like that's only one time of the year, one season. Once a building has given you, say, a year's worth of data, is it even smarter?
Yeah, so the beauty of a neural network, without diving into the how do they work, is we're retraining them every night. So they learn from whatever happened that day, if there was anything to learn from it. But you're right, when we're changing season, that's where they learn a lot. Because let's say an algorithm that only knew the summertime, as it's getting into the September, October, November, it's starting to learn that, you know what, it could be cold at night. I would never realize it. And when it's really freezing for the first time, well, it's realizing, well, now we have to use something called heating, right? So it's learning through these every day as it's moving forward like that. So after a full year in one given building, you could say that a good chunk of the learning is done and accomplished. And then the future learning will come from behavior change from the occupant of the building. So let's say you have a new tenant which occupied that floor, which is having a different behavior, then we're going to learn from it. But on the weather side, you're not going to learn so much anymore, except if you have exceptional weather event that sometimes happen.
And so it's constantly adapting. And so if you, for instance, you said, you have a different tenant, but like, let's say you move the furniture around or you put up some drapes. Normally with a normal system, it would just say, it's 6 o'clock in the morning, time to blast the heat. And because of those drapes, it's going to make that front lobby or that office way hotter than it was originally intended. But there's no learning taking place, so it just blasts that up to a hotter temperature. And everyone's just like, why is it so hot in here? But you're saying that after some time, the building is going to be able to figure out, hey, this room is different. Something about this has changed. I'm going to change the algorithm?
Yeah. It's funny because it realized that something changed. It will not know it's a drape. It will not know because it does not see what's in that room, but it will know it changed and will understand what's the impact on the thermal behavior of that room, and it will adapt to it. But if you ask the AI, do you know why it changed that thermal behavior? It will have no clue why. You will have to physically go on site and see it by yourself. But really, is it important to know that it's the drape or if it's a chair or if it's a desk? You want to know what's the impact on the thermal signature and adapt to it. So in some other situation, which is quite interesting, if let's say they change the window, they put a better window in that building, we will immediately understand the impact of it and adapt to it without telling anything. So that's another type of example where you see as soon as the building owner or the building operator start to change some things in the building, we immediately see the impact on the thermal signature of the building, and we learn from it.
Now, how long do you think it's going to be before all buildings in the world are smart? Because it seems like for decades, and longer than decades, most building owners and engineers have, like you said, they've learned a certain way of running a building. Make sure that the minibar is working. That's my job. Make sure that the boiler's not broken. But they haven't been trained to do what you're doing, which is to make the building smart. So is this going to be a fast change like we've been talking about on the show, like an S-curve where all of a sudden, before we know it, all buildings are going to be smart? Or is this going to take decades to unfold?
I think it's going to go quite fast. I mean, the building was left on the side with very little innovation for so long. Then as soon as people realize, there's an interesting space where you should apply technology, it's gonna be massive. I mean, we're already seeing other companies which look at what we were doing and they're changing their language. They're now recognizing that, we should go in that space too. So I could already tell you that we're probably going to have followers quite rapidly. So the race is on that. and it's a race all for the good reason. That technology will be massively adopted and it will be used, and we're all going to benefit from that usage, right? So I mean, I see this happening quite rapidly due to the fact that really the upfront cost is so low that there's really the reason not to at least try it in your building. So usually that's the trigger, right? I mean, what's the barrier to entry? And in this case, it's a very, very little barrier.
To go further on that point, let's say I'm a building manager, or I'm a business owner, or I'm a building owner, or I just think that it's interesting and I want to implement it at the company where I work at. How much would you expect the upfront cost to be versus the cost savings?
Oh, it's very, very little upfront cost. I mean, for us, we're trying to develop that technology so it's going to be onboarding by itself. So we don't even want to throw human at it as to configure it or install it. So we want to be like self-install, self-learning. So it could be just happening by itself. We're not there yet. We still have to have a building engineer on our side to configure it, make sure it's properly onboarded and installed. But when you look at how many hours it takes, it's very, very low cost. You're talking about in between 1 or 2 months of payback for the install.
And just for our viewers who might be interested from an investment side, I mean, you guys are a startup company, right? You're relatively young.
Yes. So we've been developing that technology for the last 3 years. Mind you, when you talk about neural network, everything is young, but it's moving very fast. So. And we apply that thinking of neural network, that technology, to the building HVAC environment. But at the number of buildings we're connecting per week right now, I could tell you that it's quite an exciting adventure, and let's say we're working very hard right now.
That's great. Well, thank you for your time. I know that you must be busy connecting buildings as we speak, so I'll let you get back to work saving the planet. Thank you so much for talking to us today.
Thank you for having me.
Okay, so did that change your mind at all on the fact that buildings have been dumb?
Yeah, I mean, I always kind of pictured that we had solved buildings, that we were running them just about as efficiently as you could. And, I mean, because when you think like, oh, you have all these different settings so that way it doesn't turn on the weekend, and it, make sure that it turns on before everyone gets to work, that seems really smart. Seems like that's as smart as you can get. I didn't realize that there are ways to make it even smarter than that. But the really crazy part to me is how you don't have to be that smart. AI doesn't have to know everything about the building.
What do you mean?
It's like dumb smart. Like, it doesn't know that, say, you've installed drapes or something like that. It doesn't know that you've changed part of the building, but it's going to be able to adapt and change depending on all sorts of different conditions.
Doesn't it have to be smart in order to work properly?
Well, no, because, I mean, using this example, smart would be, having a team of engineers that would go around and measure things like, oh, the thermal conductivity of this wall is this much, and the thermal properties of this room are such and such, and they'd have to measure it, and then they would create some kind of program that would work. But as soon as something changes, as soon as you move a desk around, it's going to slightly alter the way it works. It's kind of like walking. Like, we are, as humans, we're pretty good at figuring out how to walk or how to do something like that. And even when something changes, like you get a rock in your shoe, you're still able to walk, right? It's not like you're like walking along and all of a sudden a rock is in your shoe and you're just like, whoa! That doesn't happen.
So basically what you're saying is using neural nets is how humans learn. I mean, when you're a little baby and you pick something up and you just start chewing on it to see if this is something that's good to eat, you learn that it's not, but you learn that in a dumb way. I mean, you learn by picking up everything around you and testing it.
You know how we're generally pretty intuitive when it comes to physical objects? You know that if you kind of stick something out on the edge, that it's going to fall over. You don't need to sit there with a graphing calculator and be like, okay, let me do some math and figure it out. We're able to adapt rather quickly and have a dumb, smart understanding of what's going on. We don't need to back it up with any math. And that's kind of what the AI is doing. It's able to just be like, this room seems to be getting cooler faster, so therefore I'm going to need to change the way my algorithm works in terms of how I'm going to heat it up in the morning and how I'm going to let it cool off in the afternoon. I think that's really interesting, to have a constantly evolving thing that doesn't need to go take measurements and make assumptions, because as soon as those assumptions are wrong, the whole equation's off.
And I think what's also interesting is that this technology is going to be adopted really quickly, because once you see your competitor, let's say across the street, running a hotel with this BrainBox AI installed, you cannot not install it. Like, you're going to be forced to install it, just even if you didn't believe in it, just because it's going to save so much money that you can't compete with a dumb building.
Right. And so it doesn't even really matter what kind of building it is, if it's, an office or if it's a hotel or if it's, anything like that, because the rents and everything for that are going to be dependent on how much energy that uses and how expensive it is.
Yeah. I mean, I had no idea that you could save that much money. I mean, because I thought that buildings were already getting pretty smart in the sense that, like you said, like thermostats, but the fact that you turn on a thermostat and then you're just waiting for the room to get warmer. Whereas with AI, it learned like, oh, okay, it takes 12 minutes to get this room to that temperature. So I'll just, I know exactly when to turn it on.
And I'm not thinking in terms of a big building, right? Like, I'm just thinking about heating my apartment. And heating my apartment is still pretty expensive. It's, $50-$60 every month. If you're talking about a building that has hundreds, if not hundreds upon hundreds of rooms and multiple floors, and it's happening every single day, every little change that you can make, because you might think, oh, I get home and I turn on my thermostat, 5 minutes isn't going to make that much of a difference. In a huge building with hundreds and hundreds of rooms, 5 minutes is hours and hours of heating time.
Right. Saving a few cents per room per day multiplies out really fast to save all that money and all that energy, which means all that CO2.
Right.
Because he brought up a really good point, which was that even in Montreal, where you're using green electricity, that green electricity could be used. You could pump it down here in New England for us to use instead. So all that energy has an environmental cost as well. And if we can, I was just blown away by the fact that I thought this would take decades to implement.
Right.
But the fact that you've already got most of the gear you need in a big building. This isn't like turn of the century, 1800s buildings. These are already very high-tech buildings with really high-tech switches. So as long as you can somehow connect to them and get that data, then you're off to the races.
It's really interesting how it's piggybacking off of existing hardware. I was really expecting that they would need to go into every single room, install some kind of sensor suite in their own heating system. And no, you're able to piggyback off the existing one and all the different sensors with pumps and stuff like that. That's really, really smart. To have 6,000 data points in a building, that's insane.
So, we're talking every week about, electric cars and how you should put solar on the roof. And those are all important parts of this puzzle. But I hadn't realized how important making buildings smart is another part of the puzzle.
Right, because I was always thinking of it in terms of efficiency, of adding insulation or changing out your windows to more efficient windows, or putting in a geothermal heat pump and heating the floors, or putting a solar-powered heat pump, all sorts of different ways to kind of make the building more efficient, when the building itself could already be more efficient. I think that's just fascinating.
Anyway, thank you for joining us, and thank you so much if you subscribe to the show, because I got to be honest, one of the reasons that we can get the CTO of a startup company on the show is because when we reach out to them and we say, hey, would you like to be on the show? You know what they first do? They look at our subscriber numbers and they say, is it going to be worth talking to you guys? And if they see that we've got, over 100,000 subscribers, they go, oh, yeah, I'd like to talk to you. Right. And by talking to us, they're talking to you. So thank you so much for being a subscriber. If you're not already, go ahead and click that button. It doesn't cost you anything. It just helps grow our channel.
Thank you so much for watching. Now you know.